Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we're going to answer a question about electricity from October-November 2011. October-November 2011, variant 33. Let's go to the question. The question is number 7. What they say. The figure shows a circuit of, containing a 12-volt power supply, some resistors and ammeter, whose resistance is so small that it may be ignored. Okay, we have a 12-volt battery. Now the main circuit is connected in parallel. As you can see, we have different connection. Now part of it's in series, another part of it is in parallel, but the whole circuit is in parallel. Okay. First question, what they ask: determine the potential difference across the 2-ohm resistor. Now, as I told you before, now we have the 2-ohm resistors connected in series with what? With a 4-ohm resistor. So that means both of them, they are sharing the voltage, which is what? 12. So to find this, we have to know that we can do it in one step, or we have to do it in 3 steps. So I will show you the long way, then I'll show you the short way. We have several ways to answer the question. For example, here, because we are looking about these 2 resistors are in series, so R in series for both of them, it would be 2 plus 4, which is what? 6 ohms. This is the first step. Second step, I will find how much is the current that passed through the circuit. And we know that V total equal I multiplied by R in the series, and the 12 volt equal I multiplied by 6. So that means I equal 2 ampere. This is the second step. The third step, is to find how much is the potential difference, the voltage across the only 2-ohm resistor, which is equal I multiplied by R for the only 2-ohm resistor. And we just find I, which is 2 ampere, multiplied by the resistance, which is 2, and the answer, it will be what? 4 volt. Now, this is the long way to answer the question, 3 steps. Now, the short way, you can use another way. The short way, since both of them, they have the same current here, since both of them, they have the same current, that means the current is the same, which means that the V for the 2-ohm volt divided by the resistance of the 2-ohm equal V total divided by R combined for both of them together, since they are connected in what? In series. So that means V over 2 equal 12, the voltage total from the whole circuit, divided by 2 plus 4, and by using the calculator, we will get the same answer. That's V equal what? 4 volt. Okay, that's first part. Then what they ask, state, that means you already know the answer. State the potential difference across the 3-ohm resistor. Now the 3-ohm resistor and the 6-ohm resistor, both of them, they are connected in parallel and directly to the power supply. That means we don't have to do calculations. So the answer is 12 watt volt. Next part, what they ask, calculate the effective resistance of the 2 plus the 4-ohm resistor, they are connected in series. We just find it out here. So that means the R in series equal R1 plus R2. And the answer is 2 plus 4, and the answer is 6 ohms. Next question. The 3 and the 6-ohm resistors, they are connected in parallel. When they are connected in parallel, so R in parallel equal R1 times R2 over R1 plus R2, the product over their sum, which is equal to 3 times 6 over 3 plus 6, and the answer by using calculator, it will be 2 watt ohms. So far, it's easy, right? Okay. Calculate the reading of the ammeter. Now, the reading of the ammeter here to get the reading of both resistors here together, and the voltage across all of the circuits is how much? 12 volt. So that means to find that, now V total equal I for these 2 in parallel, multiplied by R in parallel, that we just find it out, which is what? 2 ohm. So that means 12 is equal to I multiplied by 2, and the reading of the ammeter, it will be what? 6 ampere. Last part here, D, without further calculations, state what will happen, okay, if any, to the ammeter reading if the 2 ohm resistor is shorted out with a thick piece of wire. Now, if we put the 2 ohm resistor instead of it as a wire, okay, and there's no resistance anymore, this will not affect the reading of the current because the current will only be affected by the combined resistance here and this joint circuit from here to here. That's it. So no effect. No effect. Okay. But double I, the thick piece of wire, and from DI, this one, okay, that doesn't have effect. And the 3 ohm resistor are both removed. If I remove this one, okay, that means there is no current here. If I remove this one also, that means the combined resistance, instead of making 2 ohms, it will be less than 2 ohms. It will be only 6 ohms. So what happened to the reading of the ammeter? Since the current, we have the same voltage, the resistance increases from being 2 to being 6. As the resistance increase, the current would decrease. So here, decreasing in reading, decreasing in reading. And that's it. Good luck. Ciao.